I think we are live now. So on my screen, I'm trying something new today. I'm going to be playing some fun videos while we're also doing our experiment. We're just going to let a few people come on first, and then we'll get started. So today, welcome to the nature class, my outpost, and we are going to be doing snail slime. This experiment is also really fun for quicksand. So we'll be doing some of that too. So we'll just wait for a few people to come on, and then we will get started. If you'd like to join in on the activity, you are going to need cornstarch and water, a bowl, and then something to put your experiment in. There we go. So you're going to need a bowl, cornstarch, water, and some kind of newspaper or material to cover up your workstation, because this is going to get messy. Let me turn on the comments. If you want to let me know where you're from, and if you are tuning in from Instagram or Facebook or YouTube, I'd love to know. So again, today we are doing a slime experiment. This isn't going to be your normal slime with glue and what you see in normal experiments. We are going to be doing slime experiments that kind of show how snail slime works. Okay, so what you're going to need, again, cornstarch and water, and that's it. And what we're going to get is this very cool, slightly liquidy, let's see if I can get it. You can see it's like liquid, but when you poke it and stuff, it's not going to be liquid. You'll see when you do this. I promise you it's going to be so much fun. So start by pouring the water into your container. Make sure we see each other very well. There we go. And then I like to add food coloring. I think it's really fun. So I'm just going to add a little bit of green because we're doing slime. And then you're going to slowly add in. So this stuff is going to be so cool. You're going to slowly add in your cornstarch. Let's give this a good mix. So what makes this different than other slime is that it's kind of tricky. So it has the polymers, which are chained molecules like our normal slime does with our glue. But this slime, when it mixes with water, it causes a special kind of mixture called a colloid. And what this does is when you use it, what's the right word? When you are very easy with it and when you stir it, it's like a liquid form. However, when you put pressure on it, like when you poke it, it turns into a solid form. It's really cool. Again, this activity works really neat if you're trying to explain quicksand as well. So you're going to slowly add in the cornstarch. You want to do it slowly because when you try to push too much at once, it will turn solid on you, and we don't want that. Just slowly add it in. So the reason why I wanted to highlight snail slime is because snail slime gets kind of a bad rap. It's so much cooler than what people think. So snail slime is mucus, just like our snot. And just like our snot, it's used to keep the animal wet as well as to protect it. But what's really cool about the snail slime is that it's actually a liquid crystal. It's a mix between kind of like a solid and a liquid. And it's used to lubricate, so make it a lot easier for the snail to travel, right? That's how we kind of know slime as. But what it also is really good at is as an adhesive. So it makes the animal, it enables the animal to climb up like buildings and rocks and plants and still be sticky. And so what scientists are using this for is they're trying to figure out a way to mimic snail slime so that things can still be sticky, but also very flexible. Because if you've ever used like super glue, you know that it gets very sticky, but it also, once it dries, it's just hard to use. It's very stiff. And so what snail slime does, oh, it's starting to work, is that when they're moving and they're gliding, it's very liquidy. But when they sit still and there's pressure on it, kind of like what we're going to do with this thing, it becomes very sticky and very much like a solid, much thicker. Okay. I think we might be good to go. Okay, so see how it's very liquidy, but then if I try to jab it, oh, you see? It's starting to tune. Hi, Heather. So it's starting to turn like a solid. We're going to turn, let's see. This is going to be so fun. I think I'm going to need cornstarch, more cornstarch. This is better. Okay. So watch, I'm going to put it in my hands. Let's give a little bit more of a stir. Oh, it's so hard to work with. Okay. Okay. Let's see if this works. So I'm going to put it in my hands, and it's going to be super gooey and goopy. It's like real slime, right? So it's super gooey, but then if I try to grab it, look, it's almost like a solid. So it changes from this really liquidy form, and then when you try to jab it, look, that's all solid. So this is such a fun experiment. If you do decide to do this experiment, make sure that you do not put it into your sink or down your toilet because it will clog it. So again, watch. So it's super liquidy, and then as soon as you apply any pressure to it, it feels like a very thick solid. So as I'm playing with this, let's talk a little bit more about snails. I was looking for one earlier and I couldn't find one. So for those of you who are coming on, I saw a few more people come on. We are making a special kind of slime. And what the slime does is it's very liquidy when you're very gentle with it. Kind of like the way when a snail or a slug is gliding across the leaf. But then as soon as you put pressure to it, it becomes a solid. It becomes very hard to manipulate. You see, it becomes, let me see if I can really get it. So it was a liquid and now it's basically a solid. So really cool. So what's also unique about slugs and snails that are cruising around in your backyard is that they have this really cool air hole. If you ever look right below the shell, you'll see this air hole, and that's where they breathe out of. And they have a really neat tongue. It's called a radula. And on this tongue, they have these tiny little teeth all over the place. And that is how they eat. They almost eat it like filing down and shredding the leaf to eat it. And I know they can cause a lot of damage, but man, they are such cool animals. And their slime is just so, so unique. And the reason why you see the slime when they make the trails is because they're constantly producing the slime. And so not only is it left behind because it's, extra, but also it tells other snails what's going on. So they use it as a form of communication as well. So they use it as protection. They use it as a way to glide across leaves and sticks and to get around. And then they also use it for protection. Another thing that snails do that's really unique is they can form kind of like their own cocoon. If you've ever gone to grab a snail, whether it's a sea snail or a snail in your garden, sometimes they're kind of hard to pull off whatever substance that they are sitting on, whether that be a rock or, oh, look, when you put a lot of pressure on it, it crumbles and then it turns back. Oh, I can play with this for hours. So they can create this really cool attachment, almost like this grip by taking its slime, letting it dry, and then that slime becomes so strong that it creates this protective barrier over it. But that is it for today. If anybody has any questions, please let me know. And I guess we'll have story time tonight. I highly recommend doing this activity because I think I'm going to be playing with this for a few hours. It's messy, so make sure you guys have something underneath. And that is it. Until next time, this is Miss Mallory inviting you guys to step outside and adventure when you can. If not, learn about nature all you can. I have no idea how I'm going to turn this live thing off with these really nasty hands. But bye, everyone.